Welcome to our last lecture on Module 2. Today we'll be introducing you guys to the system of differential equations and how we can solve them using basic substitution and elimination method. My lecture on systems of equations at this point will be a very basic and introductory one. We'll get more into it once we cover the chapter on Laplace transforms. Looking at the first glance to systems of differential equations, if you look at what I've written up here, x double prime plus 2x prime minus x plus y double prime and so on. Make a note here, guys, that x prime and y prime are not just independent variables. X and y themselves are functions of t. So when I'm writing x prime, I basically mean x prime of t. And when I'm writing y prime, I basically mean y prime of t. So here t is my independent variable and x and y are my dependent variables. And a solution to the system of differential equation would basically mean I need to find these two things. I need to find x of t and y of t. And that's what we're trying to look for and find. Now, again, make a note that whenever you see x double prime, if I wanted to convert that to a differential operator notation, as I've shown this to you before, x double prime, I could write it as d squared x, which means the second derivative of x. Let's practice taking a differential equation and writing it in a differential form, because in order for us to solve these systems of differential equations, we need to first put them in a differential operator format. Now, the above differential equation that's given to you here, the x double prime plus 2x prime minus x, if I take this and actually try to convert it into a differential operator format, you notice x double prime turns into d squared x, 2x prime becomes 2 derivative of x, minus x, there's no derivative there, so there'll be no d here. Then y double prime becomes d squared y. Minus 3y is just minus 3y. Since there's no derivative there, there'll be no d here, equals sine of t, and you convert the second line as such. Then we call this differential operator notation, and then we could simply factor out the x and the y from the 4 curly brackets, and then we could basically see how our system of equations will come about. And then we'll just go ahead and solve these things based on using the elimination method and the substitution method. So I'm ready to give you an example on how to do this. So let's actually look at an example and go through it and solve it. Say I've started with a system of differential equation that I could write as x prime. Again, that means x prime of t in reality, but I'll just, for sake of simplicity, I'll just write it as x prime plus y prime plus 2y equals 0. And my second will be x prime minus 3x minus 2y equal to 0. Well, in order to solve this, what I need to do first is to convert this to differential operator notation format. So this will be, x prime will be derivative of x plus derivative of y plus 2y will be the derivative plus 2 times y equal to 0. And that's how you write that. For x prime and 3x, it will be a differential operator at a constant of 3 for x minus 2y. And again, there's no derivative for 2y, so there'll be no d for 2y on the conversion either. All right, well, now we look at this and we try to decide if we're going to eliminate x or we're going to eliminate y. Let's try to eliminate x here. Well, in order to get rid of x, I have to multiply the top equation by the differential factor of d minus 3, and I need to multiply the bottom by the differential factor d, and I need to turn one of these into a minus so I can subtract them and eliminate them when I'm actually adding them together. All right, now adding these two equations together, which is what we do when we're using the substitution method, will give us, and multiplying it, of course, with the constants, will give us d minus 3 times dx plus d minus 3 d plus 2y equals 0. And then for the bottom one, I'll have minus d minus 3x plus 2dy equals 0. And now I can cross cancel the first two. So I add the two equations together at this point, cross them, and then I will have only my y variables left. So if I add these two together, I'll have d minus 3d plus 2. And then I have another 2d from the second equation, and all that's applied to y, and that's equal to 0. So I've eliminated my x variable, my x function, and now I'm only looking for my y function. Basically from here, I need to solve for y of t. Now here, if I simplify what's inside the brackets, I'll have d squared plus d minus 6y. And guys, this is a homogeneous second order differential equation, and you can see the characteristic equation is already showing itself. So basically my characteristic here will be m squared plus m minus 6 equal to 0. If I factor this, 3 and 2, so you get a positive 3 and a negative 2. So my roots are m is equal to 2 and m is equal to negative 3. So then I can simply write my solution, which remember is a y of t we found here, as c1 e to the negative 3x. Sorry, that's not an x, that's a t. C1 e to the negative 3t plus c2 e to the 2t, and that's my y of t. So I have one of the equations appearing in front of my eyes now that I've solved it. So there's my y of t. Now, in the substitution and elimination methods that you learned in algebra, at this point you did substitute it back into your equation and went from there. Here, you don't touch this y of t, you don't substitute it back into anywhere. All what we do is we go back to the beginning of this example, to this differential equation, which was here. I'm going to use a white color here so you can see. So we go back to this, and we're going to try to solve for y. And you can calculate x of t the same way by eliminating y and calculating x of t. And I'm not going to do that because it's on your PowerPoint. So your x of t will be c3, could be your third constant, e to the 2t plus c4 e to the minus 3t. And that would be your x of t. And here are your two solutions for the given differential equations. You have your x of t and you have your y of t. And that will do it for our lecture on Introduction to Systems of Differential Equations. See you guys next time.